So I'm Brian, even though I'm standing on this side of the screen. That's
And
Craig.
we didn't plan that
standing
well.
over there. And then Cameron, who's in the middle, just isn't here. But Cameron's a great guy. So if you see him, chat him up.
Absolutely.
Great guy to know.
On multiple topics.
So for dropping names, Cameron's a really good architect guy to know.
Yes. Well, have we hit the time? Or do we got a minute? Where are we at here? Oh, we got 1 minute.
Do you see anybody walking down the hall? And the guy on the camera's on, so we're good.
Camera's on. We got a crowd. We're ready to talk.
Okay, 3, 2, 1, go.
And everybody's here to talk about storage, right? Okay.
I hope so.
Because that's what we're going to talk about.
Yeah.
If you're not, feel free to exit. What is your guys' favorite session so far? The last one?
Yeah, you've only had one so far.
Breakfast.
Yeah, that was a really
I like
good
this
session.
guy.
God, I love that bacon. That bacon was so good.
That's my favorite part about coming to these shows. Mm-hmm. You can get a big old plate of bacon. The eggs are, yeah, but the bacon's always good.
Bacon was tasty.
And the wife doesn't complain.
What's that?
I'm hungry now.
Oh,
Yeah.
okay. Well, we stand between you and lunch.
So
this
we
is
are
a
going to get
topic of
rolling.
Conversation.
Exactly. So welcome and introductions. Brian, how long you been at this?
So I've been in a role that supports this kind of thing for over 20-some years. Been with SUSE for 2 myself. What about you?
Well, you were part of the mothership earlier.
I was part of the mothership for 22 years before that.
So I've been in this pre-sales role for just a few years, like Brian. But prior to that, I'd spent 10 years in consulting, actually implementing SUSE technology for our customers. So we've been at this, and then prior to that, I've done development and a variety of other things. And so together, we've been at this for a long time. And one of the things that we wanted to talk about is, why is tuning important? This is one of those things where you get it installed, you get it running, and you go, yes. You think you're done, and you really got to look at this on an ongoing kind of basis. So that's the first part.
And coming from environments where there's obviously tons of different storage options available in the world, and then dealing with what we call software-defined storage, there's a lot of things you discover, things you learn over time. So we thought, there are some, without everybody here trying to get their PhD in software-defined storage, we thought, well, what are some just things you do every time you deploy something? Right. What are some go-to things to help get you off the ground and then help you as you own something for a period of time?
How to maintain it.
Yeah, how to maintain it for some time. So we came up with, why tuning is important, some best practices from an architecture perspective, and then some tuning approaches and the process around that. And let's always be planning for performance.
Right.
And so what were we talking about today from a performance
Some
perspective?
of those IOPS pieces.
Yes. Or just in general,
right.
if you're ever looking at, in a technology like this, if you're looking for ways to make it faster, which is kind of a cool thing because you have the ability to do that with software-defined storage. In some of your traditional stuff, you kind of don't have a lot of choice.
Right.
You can pick the speed of the drives, but then you're done. But consider things like high-performance computing.
Right.
We were discussing. Great place to find ways to tune for performance.
Yeah,
and
to
so
tune.
Planning for performance was great. Then we have some tuning specifics we've outlined. Here are a whole bunch of really good things to just keep in your back pocket. Always good things to do. And then some.
And then we got some war stories.
And some. And then some resources.
Some hard word.
Some places to go to find things.
Yeah. So why? It's just like your car. You drive it off the lot. It's driving spectacularly. 40,000 miles from now, not so much. So, you hit that performance problem. It's not quite going fast enough. Or I was talking to one of you guys earlier. It's like, do we know that it's performing well? We may not even know it's performing adequate. I don't get complaints. But could it be performing
the lights
better?
are blinking, drives don't seem to be failing, so
nobody's calling me with errors.
As far as I know, I'm good.
But there may be real issues under the covers, or you might be able to get more performance and impress those users of the storage even more, or be able to add more systems to it or more use cases. And as you do that, you will see degradation of performance. You know, all of a sudden you had 80 users using it for unstructured data. Now all of a sudden you've got some automated processes dropping videos onto it, or you've got something else going on, or you upgraded the backup solution, and now all of a sudden it's no longer performing as it should. So as you make changes to your environment, you may need to readjust things. And it's not just software. The hardware's got to work together with the software-defined storage. So if I'm putting together a storage cluster of old equipment and 5,400 RPM drives, I'm not going to get it to perform well. You know, it's taking that 1998 Honda Civic and trying to make it do 140 miles an hour. You're not going to quite get there. So that's one of the things that we do want to talk about as well. So the architecture matters because that's the base component. So your hardware components, your networking, those are things that are laying out your base limits. So sometimes this is those architectural limits that you can't configure around to get faster. So things like the number of servers, the number of drives in each of those servers, the types of configuration. Maybe it's a hybrid config of solid state and spinning. You've got to make some choices here because this is the integration of that hardware and that software piece to build the overall solution and the overall storage cluster.
And I think we'll talk about that particular point several times.
Yes.
And that's all around this notion of analyzing your workload. What is it that I plan on putting on here? What kind of workload is it going to be? What's my use cases? So that I can then tune it specifically for that.
Exactly. And this actually says it better than I was trying to earlier. It becomes the hard ceiling. It's only going to go that fast for the amount of hardware and the kind of hardware that you're putting in place. And then misconfiguration. You know, I don't know how many of you guys go back to old school networking issues. All of a sudden you plug in that misconfigured router or a misconfigured switch and the whole network performance goes to crap. That's part of what we are looking at as part of this performance tuning. And then this one, as fast and as large as you can afford. Because oftentimes from a budgeting point of view, you only get to go to the well once when you're going to go buy that hardware for a storage cluster.
And it touches on the things we were describing, the architecture, the network connectivity between the server nodes. You know, 1 gig Ethernet's just not going to be what you want for a back-end solution like this. We're talking 25 or 40 gig, or what can we afford today to give us the best performance to move that data?
And maybe it's you know, as my son says, it's a budget build for his little Honda sports car. And maybe it is a budget build, and maybe 10 gig is what you can do. But get as fast as you can afford. And
the cool thing with software-defined storage, and I was just talking to Elaine, there she is at the back, is it's really easy to add and upgrade and change without a rip and replace of everything. So let's say you start with 10 because that's all you have today. We're going to do the best we can with 10, but know the minute that we can do 40, I expect 4 times the performance out of that.
So let's talk about the hardware components, because one of the things, as we start talking through the tuning pieces, we'll talk about some of these individual components for Ceph, and we just kind of want to make sure everybody's on the same page here.
Yeah, and if you saw this in a rack, you might not, from a distance, you might look at that and think that looks just like a regular SAN storage. It might not say, you know, Dell EMC or something on the front, but it's just a whole bunch of drives, some servers that are doing what we call monitor nodes that are watching the cluster, and they're sort of the brains behind a lot of what goes on in the cluster. Then we have gateway nodes, and they're the ones that most of your servers and things will interface with. So the things that are asking for or providing data to be stored or read, they're all going to go through one of your gateway nodes. And then we have an admin node that just is where you install software from, and it's sort of an out-of-band kind of guy. He's not really as important as those other nodes. And in some cases, you're going to have hardware that requires maybe an IPMI server or IPMI switch or something that supports that, but you need something that has networking connectivity. This is not rocket science. This is real easy stuff to put together.
Right.
But the speed of these servers and these drives will all affect sort of the output of what I'm going to get from my cluster.
Exactly. So let's talk best practices a little bit. And these are ones that David Byte, Cameron, Alejandro there have helped to put together of this is good starting points to get a solid storage cluster put together. So we got an admin node, 6 gig, quad core, very simple, straightforward pieces. The monitor nodes, higher on the RAM kind of capability. Quad core want to have some faster disk in those monitor nodes to accomplish the tasks that they're given in the cluster.
Now, the one thing I would call out, while we say the admin node could certainly be a virtualized component, we kind of, tongue-in-cheek, say monitor nodes can be virtualized. I don't know that I would. I really like physical for those guys.
Alejandro, virtual versus physical in a production cluster?
Depends on the scale. If you have a virtual system very close to the cluster, that allows you to reliably put them there. So they're not
Perfect.
storage bound, so they could.
Right, they're not storage bound.
They're more CPU and memory.
But
It also depends on the resource utilization for the VM host.
of the host.
Yeah.
That's exactly what I was going to say. If you've got a host that's already doing your email and a couple other things, that might not be a good place to put your monitor nodes for this. Because this is running your storage. These
Right.
guys are a key component to just the flow. I mean, your data is stored down here, but these guys, they know a lot about what's going on in the cluster. Question?
In particular, they're the ones who figure out whether the OSDs are still running. And if
Right.
they get starved for network.
Right. And if you're starved for network or performance or CPU time or whatever, there could be some degradation. So I just wanted to call out, we say yes, they can be virtualized, just be careful where that might be. Physical would always be best. Even, and we're not, like Alejandro was saying, it doesn't have to be the fastest server out there, it just has to be something. And I like physical.
Reliability is more important.
Yeah.
Right.
Yeah.
And then the OSD nodes. And these are the servers that actually have the disks in them. So these, the number of nodes is really going to be based on how much storage do I need to have. What's that number that I need to have as a starting point? Because keep in mind, that's one of the other beauties of software-defined storage is, next month I need another 100 terabytes. Let's add another couple of nodes. You can grow it as you need to. So this is based on the usable capacity that you're striving to get. And then there's some fairly specific formulas that you need to use to build out the size, the amount of memory, CPU constraint, or the CPU components for the storage nodes. And those are very, very important to hit these from a performance perspective. And again, like Rick just mentioned, reliability is huge in this space. So you want those reliable machines.
And this starts to begin the tuning process in that the more OSD nodes you have, and consequently the more drives you have, that's more the spindles you have that you're writing to, so things tend to go faster. That's true even when in the SAN world. The more drives you have, things get faster because you've got more spindles. But remember, every node has got more RAM, added more RAM to the cluster, another processor to the cluster, so things tend to speed up as things go by. We've got a question in the back.
So in the formula there for RAM capacity, it says 2 gigs times OSD capacity as in gigabytes, terabytes.
And that is by gigabytes, I do believe. Oh, terabytes, excuse me.
You mean for Blue Store?
This piece, 2 gig times the OSD capacity in terabytes.
Gotcha. Okay. Question?
You say 2 SSDs are faster. What do you mean by or faster? Under OSD, OS disk?
Right here.
No, down below? Oh, there too, yeah.
Or
So-
NVMe.
Notice this is for the OS
Yep.
part. And so because we are a cluster of servers that make up the storage array, having your OS part, that's where your boot times and everything else like that, having those on SSDs just give you better performance.
And-
What I'm getting at is, what does or faster mean?
So NVMe,
Sorry.
so solid state disk in the memory bus,
Yep.
for example, there is solid state memory that is
NVMe
faster.
are also SSDs, right?
Correct, but it's a different access methodology.
Yeah.
It's not serial.
And then in 10 years from now, since we won't have something else, this will still apply.
Right.
We can still use the slide. So SSD are faster. We were thinking ahead.
Yeah. So let's talk about IOPS. This is one of those key terms, and it's one that I didn't understand well before we started working through some of these pieces and I started doing more of the storage pieces. And it really is, it's the input-output operations per second is what it stands for. And it's really tied to the performance and the physical characteristics of the drive because it's a simple mathematical calculation. And it's the average latency plus the average seek time, 1 divided by that to come up with the number of IOPS. Notice as we go through and look at a 7,200, 10,000, 15,000 RPM drives, the number of IOPS changes. So this is really all about the physical characteristics of the hard drives you're putting in. Again, this comes back to the hardware gives you your hard ceiling of what kind of performance I can expect. So if I'm putting in 7,200 RPM drives, I can only expect 80 IOPS per drive. So if I have requirements of far higher than 80 IOPS, guess what? I'm going to either need to do faster drives, meaning higher rotational RPMs, or I need to do a lot more of these. So this becomes sort of that foundational building block of that physical architecture dictates what kind of performance I can get out of the device.
Are there any rules of thumb to anticipate how much your IOPS might increase with caching SSDs?
I'm sure there is some rules of thumb there. I don't know what those are as far as what that might get you. I do know, like with Blue Store, and if we do the SSD for caching the writes, we do get increased performance. I don't know if there is a 10 or 20 or 30. Alejandro, do you know? Or
So until that write-ahead log pretty much fills up, then you're almost going to get the IOPS of an SSD. Then once you pretty much hit that cap, then
it's going to degrade.
But yes, I mean it's going to depend on the amount of drives, then the size of the wall in the DB, and some other components. But that's why we always front the fitting drives
With the caching, with the solid state.
So with your IOPS, this is magnetic. Seek and IO wait aren't in that, right? So 80 is consecutive?
I believe that is consecutive, yeah. And you had a question as well?
All right, I was going to ask why average seek time is the same for 10,000 and 15,000 rotational speed. It seems like one should be about 2/3 the other.
Well, latency will decrease, but the seek time.
The seek time getting the head positioned to, yeah, it's moving the head around and that stays about the same. But the amount of data you can pull through increases because of the rotational RPM increase, or the RPMs are faster.
And these will be dictated by the drives, and they should be specified, stamped on them,
Or
you can get that information from the drive
I
vendors.
thought the big component of seek time was waiting that half a rotation for the data to get under the head.
No, that's the
Not so much
latency
moving
time.
it, or part of it.
yeah. I don't know. This is the data provided by the drive manufacturers. So there may be some of that, but this is the example pieces that we'd collected. And then the bandwidth and throughput. So notice, as we look at that calculation, the IOPS is part of that. So to get our max bandwidth of the capacity, it really is tied to, again, those physical characteristics of the drives. So that's one of those things where we were talking about, you got to be careful about how you architect that beginning level to get performance. If I'm putting in very slow drives, you know, because we didn't even show 5,400 RPM drives, for example. You know, there's some very, very slow drives that you could use.
But capacity changes for those drives too.
Correct.
So capacity goes up even though I've got a slower drive.
But yeah, even with the 7200s, you might be able to get the increased capacity than you do with the 1500s, but you're going to lose out on the numbers of IOPS. So it's just one of those things that you got to kind of look at these calculations as you are designing the overall cluster to achieve the levels of performance that you need. And potentially, it may be all unstructured data, light number of users, maybe it's archive only. You can get away with those smaller or lower speed drives, higher capacity, because you don't need the IOPS for it.
And we've got a component here that you can use as a metric as well. The I/O size, which is tied more to some of the
workload.
software configuration and the workload that you're bringing in. And your ability to tune the I/O size, and we'll have a few examples of this later, to get better throughput. So you know, these all come into play as we're trying to figure out how can we, based on the workload, get better throughput for what we need.
And this helps us to be able to calculate what is that theoretical maximum. What is that hard ceiling that we're shooting for from a performance capability? Because then you can see I'm not hitting that, or I'm hitting it. I know I'm close to fully tuned as I can be at this point.
Right, and we can't go faster. Then you're kind of set your ceiling there.
Right. So tuning general steps. And if any of you have looked at tuning systems from an application point of view and an OS tuning point of view, you'll recognize some of these overall steps, because you gotta make sure you're running latest code. You gotta make sure you got no general issues. You gotta figure out what is it that the problem I need to solve. In this case, we're really talking about performance. And then, is the degradation new? Because you're going to see as we start talking about this, is this becomes an ongoing process for your environment. If it's new, you look at what has changed. Identify why the issue is considered to be a performance problem, and this is more of those general
those
performance
first four
tuning steps.
Are you do that for everything? Monitor doesn't turn on. What did I change? You know, real easy, basic ones.
But now, when we start getting down into 5 and 6 here, this becomes, we can talk about it very, very specifically to performance tuning storage. You got to identify that metric. What is that metric that I want to use as my performance tuning metric, my testing metric? Is my use case one where I'm reading data off of the storage cluster? Or is it really one where I'm writing data? Is it database? Is it, you know, any number of those use cases? Figure out what that metric is that you can use to work with through the performance tuning process. So it's one of those key elements that you need to have. And then step 6 here is it needs to be able to be measurable. Because I may identify that it is, you know, how fast am I saturating the caching? You know, I don't ever want to saturate the caching. Can I easily measure that? Maybe, maybe not. But it's these sorts of things, specify the metric, and then be able to measure it. And then you're stepping down into the rest of the pieces where you start working through, how do I solve it?
And I think be sure you pick something that you can measure and not let it be that one person who always complains because it's just never fast enough. Because it'll always be never fast enough for them. So find something that you can measure,
yes,
that you can, you know, go back to and say, this is the answer, not who's complaining, who's not complaining.
Well, and this comes back to those last couple of slides where we're talking about understand where your theoretical maximum is. What is that hard ceiling? Because if you were looking at a budget build, your hard ceiling may be not fast enough to satisfy that one guy. But you can go, it is tuned to the theoretical, you know, we are close to the theoretical maximum for this cluster design as it sits. And then go through, and this is an iterative process. to where you go through and you may have identified one portion of the subsystem to tune, and then come back and remeasure it, and it's like, yes, I got it faster, but it's still not where I want it to be. So it becomes that reiterative process, and you just keep walking through this to get to the tuning taken care of. And one of the things that I want to make sure and call out is the fact that this isn't a one-time thing. Like the car analogy. You don't just tune the car up when you buy it. You got to tune it up on a periodic basis to keep it at optimal performance. So when you apply a patch, you may need to walk back through this tuning process and go, uh-oh, we now have lost a portion of performance. What happened? Maybe I need to come back and reevaluate the patch that I applied. Because we've got an example of that in the tuning specifics here.
And if you can measure it, you'll know right away. Did we stay the same, or did we go up, or did we go down? Let's have something we can quickly baseline with.
Right. Adding gateways. So the gateways, as we saw on that architecture list, gateways are where we have iSCSI gateways or Rados gateways, NFS types of gateways. It's where we're passing data through. If I added a new NFS gateway, I may need to go do some tuning to get the performance where it should be. Storage nodes and/or disks. So if I go through and I added 2 more disks to every storage server in the cluster, I may need to go through and retune some stuff. Adding new apps. All of a sudden, I've added 150 users, carving up some data for VMware, an iSCSI thing. I may need to go do some retuning because I'm changing the use case.
Or you might want to readjust your baseline. You may have added a whole bunch of new storage nodes or disks, and now your performance has gone up. It will go up every time you add more and more and more. So I want to know what my new baseline is.
Exactly. So measurable and repeatable. So as we were talking about on the tuning steps, you want to make sure you have something that you can repeat through. And you want to keep those metrics. I want to know, am I getting worse? Am I getting better? Like you said, you add a couple of nodes and some more disks, all of a sudden your performance may be
And there are
heading up.
times where you can find, there are scenarios where we've added NFS gateways and we got better performance up to a point. So the first gateway was there, we had good performance. Second gateway was there with the load balancer, we got better performance. Third gateway, we got okay better performance, but not as much as we did from 1 to 2, and 4 got us nothing. So now you kind of know, there's no way, based on the workload that I'm doing, 3 gateways was the max. I wasn't getting better performance with 4 and more, so why should I even try to go there yet?
So keeping metrics, use monitoring, reporting, and graphing kinds of tools. OpenAttic has got a great set of tools for helping you understand what the baselines are. And at a glance, you can kind of see, yes, my performance is staying where it should be, or where it has been. Or I can see it's dropping because of load or things of that nature. So this is a great tool, the OpenAttic that comes with SUSE Enterprise Storage. ElkStack is a great tool for visualizing that data, the test data, the measurements when you're executing the testing pieces. IOTop and IOStat runs on the client to be able to show you how much data is going through the client system from an IO perspective.
Yeah, so the dashboard and hopefully we'll have time to take a look at that, will give us a clusters view of performance. Then there are IOTop and IOStat giving us client's perspective of performance. And both would be things we want to get some measurable content from.
Exactly. And like we said, it's part of that allows you to start keeping those metrics, especially with the OpenStack piece. So some of the specific cluster settings.
Has anyone applied Spectre? Anyone not applied Spectre Meltdown? I mean, pretty much the whole world has done that by now. Anybody go back and do any performance testing after you did it? A couple people.
Okay.
What's that?
Performance testing before.
Performance before and after.
Yeah, of course.
Yeah,
Yes.
it was painful.
Yeah, you want to know what's going on.
And anybody ever see your performance go down? Everybody do your head like this. Spectre Meltdown killed us. killed us.
Well, it killed the entire industry.
yeah.
Wasn't just SUSE,
Right,
across the board. It
I say
took performance.
Us as in the IT team, the IT administrator just
Yes.
killed us from a performance perspective. So we can consider disabling that. Now notice there's a little smiley face. There's obviously concerns about disabling Spectre Meltdown. Now if you think about the storage architecture, the OSD nodes that are running all your storage, are they publicly available or not? Yes or no? Do you trust the people that are working in your IT department? Yes or no? All I know is that when we've gone through and done tests, we can enable and disable the Spectre Meltdown, at least this part in Grub. I'm not talking about going to the BIOS and the second part of this, but we can get performance differences by turning this on or turning this off. So you may-
Sizable enough to warrant having this in the deck.
And we just throw it out there, and obviously, some people might say, I just can't take that hit in terms of the vulnerability that it exposes, and I get that. But
it's significant enough.
it's significant
performance
enough
increase.
that if you could guarantee that there were no outside people getting to these back-end nodes, it's an option to think about.
Right.
Because it has dramatic performance
Do you see this
implications.
also with replicas or only distribution code?
It doesn't matter. It's a general, it increases performance.
Even in the gateway nodes, or even in the gateway services and monitor
Yeah,
services.
yeah. It's just an overall, it brings down performance or the lack of it brings it back.
It impacts the scheduler for your CPU, and every
Right.
single thing you do runs through your CPU at one point.
Yeah. It's it's one of those, we kind of bring this up tongue in cheek. We're not trying to tell people to go make your systems more vulnerable. That's not what we're trying to do. We're just saying you can't help but understand that rocket fuel in the car certainly makes it go faster than regular gasoline. And when we install Spectre, we're down to just regular gasoline versus
Or
the
less.
rocket or less
Water in the gas tank.
versus the rocket fuel that we used to have.
But it's something to take a look at. But also keep in mind, we would want to make sure you are looking at security in depth. Like you were talking about, these servers are typically well behind where any users can touch them. Because they're behind the gateway nodes, they're behind a lot of things. And so there should be able to be turn this off and still feel secure.
30%, let's say.
It's
talking
pretty significant.
Pretty significant performance. There are different tools that we've run that can measure, not from a cluster's perspective, but from a client perspective, how well are we doing? And it was very dramatic.
Mostly when peering between each other, when we have an erasure coded pool, that all it does is really use the CPU to reconstruct the data.
Yeah, probably more so than replication, yeah.
The rest of the time is probably an 8, 12. It's fair enough.
Yeah, we
It's
just had
big
to bring
enough.
it up. We had to put it in here
Yep.
for that. Also, turn on jumbo frames. Now this is a two-part piece. There's the settings that we can make, and I'm showing you them here, to enable jumbo frames on the OSD nodes and even the gateway nodes. So both OSDs and gateways, they pass data. But you also need to make sure that your switches have jumbo frames turned on, so you're not just on one side doing it, and then on the other side is not supported, and you're not going to get the benefit. So make sure you've got jumbo frames turned on, both on the switches and on your
And on the
network
clients.
cards. Yeah, on your clients. So, and it's again, these are just go-to down in, these will always get you better performance, turn on jumbo frames.
So hardware interrupts. This is something that Cameron contributed to this presentation, and it's one I'd thought about it in relation to high performance computing. Big clusters of machines chunking on jobs. But those same tuning concepts make sense for storage as well. And if you go look at the hardware vendor, they have HPC tuning guides that go in depth as to the specific types of pieces to turn off in the BIOS. there is management components built into the BIOS that steal CPU cycles. And so these guides will go through and help you tune that hardware for, in this case, the HPC, but it's the same tuning that you would want to do for a storage cluster as well. And so like the HPE guide, which is where that table is taken out of, goes into good depth as to why these pieces need to be set up the way they're set up. And it has the specifics for a variety of workloads. But that high performance compute, go through and you set some of those pieces up, and it's great tuning on the hardware.
It might not say software-defined storage over here. It probably won't. Look at high-performance computing. I kind of mentioned earlier, look for things around that area because those are definitely critical places where we can get performance back into the system.
And it's simple stuff of, turning on hyper-threading, turning off the no C states for the CPU. Very, very simple stuff, but now all of a sudden I'm getting that extra 5 or 10% out of the hardware. And so this would be on all of the hardware nodes that are part of the storage cluster. And this is the specific, the CPU C states.
Plus Tune D.
Yes?
So does all those hardware interrupts we want to turn off, those all come like from Best Buy all enabled and you have to go in and disable them? Or like, why would they get turned on in the first place?
They're turned on because they are implementing management capabilities that are coming out of the BIOS by the manufacturer. So in this particular case, this one's talking about it from HPE. HPE includes these management pieces in the BIOS that make life a little easier if you're using it for general purpose computing. But when I look at an HPC cluster of potentially 8,000 nodes, if I've taken 5% away from all of those 8,000 nodes, I all of a sudden had to buy another 100 and whatever servers. So, those guys want every last little bit of performance.
3 or 4% from every single OSD node adds up very quickly, particularly as your storage grows.
Are OSD nodes or servers?
All of the servers in the cluster.
Yeah. So think about all the things that pass data. So OSD nodes, gateway nodes,
monitor nodes.
Monitor nodes. Monitors are, again, they're not part of the cluster as far as storing the data. They're not in the path, but anything that touches the data path, I would say,
absolutely.
definitely look at turning those on.
Nodes, though, it's going to matter. If you virtualize the monitor nodes, then turning off the virtualization extensions is going to have a negative impact.
Correct. That tuning is
Yeah.
predominantly for hardware-based nodes.
It will add power because your
Correct.
states
Yeah, so your idle states will go down and your CPU states
And
will be high.
you're absolutely right. You're going to need more power, and you're going to burn more cooling as well. So it's something to pay attention to. But again, looking at it from that HPC perspective, I didn't have to buy 100 more machines. And same way with storage.
And we provide the Tune D package to help provide better tuning on that box.
And that's tuning on the OS side of things.
Yeah, yeah.
Gateway nodes.
Yeah, now gateway nodes, you'll notice that there are some settings where we default to 64 and 128. And for iSCSI gateway nodes, if you're leveraging them, we want to max those up to 512. Do not leave them at the defaults. We want to push the amount of data that we can
Push through that system.
Yes, exactly. So the queue depths need to change. Now, this one is a very specific setting for if you're running VMware as a consumer of the storage. And it's a dual-faceted thing because, as we say here, by default, the object size for RBD images is 4 meg, yet VMware is going to run at about 512. And what we're saying is don't quite go to 512 because that'll increase the number of objects. Go to 1 megabyte instead. So this does two things. So it closer aligns our block utilization to what VMware is going to be passing to us. So we sort of get better read and write performance. But VMware has this disk reclaim option. So as you delete virtual machines, you need to reclaim that space back. When the alignment's not made closer to VMware spec, the reclaim doesn't work. And it's sort of, they do it differently than everybody else does reclaim. So so we found in our tests going down to a 1 meg level gives us the ability to get closer to their number, and we get the
Better
reclaim
performance.
back. So it's a little two-faceted feature. And so here are some other things. Now, these are very specific to VMware, meaning I'm not going to go do this. This max commands is a command that is done at the command line, the
On the
ESX
client.
command line on the VMware host. And we're telling it, now we want you to match the 512 instead of the little 128 that you normally would do. So we're going to do the previous slide. We're going to bring our RBD block sizes to 1 meg, closer to them, and we're going to say, don't do the 128 that you're going to default to. I'm going to max you up to 512. And you guys will get this slide. I know you're taking pictures. You'll get this slide. I have a link to the VMware documentation that spells out a whole bunch of other, it's like a TID on the VMware side. Here's what
It
happens.
goes into
Here's what's
detail
wrong.
exactly how to go
Goes into
execute
some
this.
details and some other ancillary data that you might care to know about. Now, ATS locking is an interesting concept. If you think about it, what ATS locking does is if the drive supports this, then the hardware of the drive can have instructions to lock a certain sector on a disk for a host to write to it, but just a little sector. So this is beautiful because I'm not locking the entire drive up. But if the drive doesn't support ATS locking, then I fall back to SCSI locking, which locks the entire drive for
all.
reads and writes until the one host is done doing whatever it's locked it for. So as you can see, if I can lock just a little sector instead of the whole drive, I can get better performance. So depending on what drives support it, and VMware has a whole thing on this, as you are leveraging VMware as a connectivity source, consider turning on ATS locking on the drives where possible. And then I have another slide that says, well, what happens if that doesn't work? But those you want to turn on. Now, in my case, when I ran this command, my INT value was, I'd already changed it to 512, and I wanted it to be less so I could show you what the default was. You want to change the max I/O size to 512 on the VMware side as well. So I want to have, I want to maximize all of my values, both on the SUSE side and on the VMware side, because VMware is a huge consumer of disk. The I/O is huge for VMware because the VMs themselves think that disk is theirs. They don't know that anyone else in the world is sharing it. So the entire VMware host is constantly sending a barrage of data.
Right.
So we want to max out our values. Also, VMware has we want to leverage the multipath policy versus the most recently used policy that it defaults to.
The round robin multipath.
And the round robin multipath takes all those other things we just did, maximizing the IOs, maximizing our queue depth and all of that, and applies it to multiple paths to write and read to the disks versus just the most recently used. So it basically load balances across what I'm capable of, not just what I've done lately.
Right. So this falls into that comment where we were talking about adding that fourth iSCSI gateway didn't add any more performance. If I was just using the most recently used, I'd only be using one of my gateways.
Yeah.
But moving to having it be the round robin, I now get to use all the gateways.
And again, I have links in many of these, particularly for VMware and others, so that you can reference that.
Question for you.
Yes.
The default IOPS for that is 1,000. You've changed yours to 100. I didn't see that.
Oh, none of the rest of this matters. Ignore the man behind the screen. Those are other settings. I just wanted to point out that one particular item. It wasn't that this is a look at all these different values and set yours to match this. Only pay attention to the round robin setting.
But VMware does have some documents on switching it to IOPS of 1, which means that it will switch the round robin faster than waiting for 1,000 IOPS.
Okay.
Yeah.
I want to know where you guys think that sweet spot is.
That
I assumed it was 100.
this was the setting used at the time that we were pulling this data. I haven't gone into all the again. There are.
This becomes one of those measure it and change it.
Yeah.
And then measure it again. Did you make it worse? Did you make it better? Though I kind of where it's heading, I would guess smaller versus larger, to where you're shoving it out multiple paths more often. Now IOP of 1, that might be a little, but
That's what VMware recommends for high intensity.
is to
It's-
take it
it's
down
for
to 1.
Yeah.
Okay.
But the workload from those servers, I don't know if that warrants it. You know, I don't know. Yeah. Yeah.
Yeah.
So this was just a value. I was just wanting to pull out the round robin one here, and to show that.
Right.
Now, we talked about turning on ATS a couple slides earlier where the drives can support them. Again, we want to be able to have metrics that we can measure, because if you find that you are overwhelming the hardware with the kind of workload that you have, you might want to bring this back. Now, certain workloads won't require the ATS locking. They might be just fine and dandy with the regular SCSI locking, where it locks the whole drive. But certain kinds of workloads, like unstructured data that don't have quite the demands, might run just as well.
And it will somewhat be determined by where am I assigning the disk to that workload. Am I doing a big chunk of iSCSI and handing it off to the ESX server then to carve up? Or am I taking a specific virtual machine and handing it a chunk of iSCSI disk? So how you build that scenario will dictate which of those settings makes the most sense. Yeah.
Maybe it's too naive a question, but how does ATS locking work? Like when you're talking through RBD into Ceph where everything's objects, if I say lock a sector, I'm really talking about the logical block, which is
on the disk.
And I think that falls into what I was just talking about. Am I taking that chunk of iSCSI and handing it to the ESX host? Or am I taking a chunk of iSCSI and handing it to an individual workload? Because if I'm handing it to the ESX host, I now may have 30 workloads accessing that chunk of disk. Whereas if I hand it to a single virtual machine, I've only got that one virtual machine accessing that chunk of disk. So in that mode, moving to ATS probably is not going to cause me any performance issues. But I don't know specifically if our implementation of the iSCSI gateway, how it supports the ATS locking.
Right, and the ATS locking is hardware specific. You've either got hard drives that can do it or not. You've got chassis that those hard drives are in that support that
But
or
his
not.
point is all of that's virtualized up through multiple layers by the time it gets to the VMware when it's coming off of our storage cluster. Because it's object at its core,
Yeah.
and then we present it through the iSCSI gateway.
I mean, the sector is going to be represented by a specific number of objects in
Right.
the store. So essentially what you're doing is making those objects inaccessible through multiple layers of translation and emulation.
So there's an object locking down there somewhere in Ceph?
You know, we're digging into levels of detail that I don't know the answer to.
Yeah, I don't.
Why is this here? No, seriously, I don't.
Yeah.
No.
Yeah. So if you, so these are VMware specific settings that VMware calls out that if you're using, particularly in our case, software-defined storage, and your performance will vary whether you turn ATS locking on or off.
But I guess the question.
What's that?
Probably not.
You almost always want it on. And that's why you notice that this says in VMware 5.5 and above, it is the default. But you might be running VMware 3.x still, ESX versions, you know, and maybe ATS locking isn't going to work well for you. And I don't know what kind of hardware you have. You might have upgraded your VMware and you have older hardware. And if it's defaulting to ATS locking on, you might not have support on the hardware side because the drive support it.
This sounds like it's more relevant for VMs that are your disk. So for RBDs that are sitting on VM, that's what this seems relevant, not for the iSCSI loads.
Oh, it might not be for iSCSI loads.
Yeah.
I don't know. I don't know about the iSCSI loads. This
Right.
is just more for the VMware settings on how it's accessing the disks,
Right.
the commands that it's sending to the disk. Because it's the host, it's not it's the consumer of the disk, not the provider.
Well,
Yeah.
it makes sense if your host actually sees individual disks and control it.
Right.
If you're using Ceph and you've got an array of
Disks.
disks and you've got no clue where the data
Right.
is going to be stored, I don't understand how a host enabling ATS is going to be able to reserve portions of disks scattered across an array
Right.
that it knows nothing about.
Yeah,
And there could be pieces of this that we would have to have a VMware guy explain to us how they do disk I/O.
we'll take this as an offline question because you have me curious now as well. Because digging down to that level, what is
But if you
details
call
of this.
VMware, which is where I got this information from, you call them up. Here's what I'm running. I've got a SUSE Enterprise Storage subsystem I'm running. I've got your systems connected to it. I'm not getting good performance on the VMware host. What are some things to look at? And so I've gone and these are all the things that they've given me. These are their go-to every time. Here's how we get better performance.
And this is a lot of this is hard won.
Me anymore here.
Yeah, no, this is hard won through one of our customers that's using Ceph predominantly for their VMware infrastructure, and they were running into some issues and spent a fair amount of time on support with
Yep.
VMware.
Well, I mean, that's my use case that I'm looking at. And of course, before jumping in, I want to know all the details.
Right.
Absolutely.
So we have implemented all of these, and things are going very well.
Yeah.
And then, which is why we thought, you know what, we've had success with a particular customer doing this. I think that we should just let everybody know some things that they can do without learning it the hard way, like we had to do and spend 3 months getting there. Yeah.
So Veeam. How many of you folks are running Veeam for backup? We got one?
How many have something else besides Veeam? Everybody else, right? So everybody's got something.
These are Veeam specific tuning pieces, but the concepts are going to work similarly in other solutions. You may just have a little bit different way of
I
implementing
don't know
them.
that these are very specific to that they wouldn't work for someone else, but if you've got a backup solution that needs to get higher throughput because sometimes you're doing disk-to-disk backup or you're doing live streaming, you're trying to capture data at certain points in time and you need really fast throughput there. Here are some things that are very specific to doing that, particularly when you've got backup solutions like Veeam or someone else. And since they're here at the show, it was good to highlight them.
Yeah. So go see them in the vendor showcase booth.
Yeah.
And go ask them.
You can ask them some really good tips and tricks as well.
But replicated pools. Good overall concept there.
Well, because it's faster than erasure-coded pools that are more processor-bound. And that was sort of what the discovery is. When things are just replicated and not erasure-coded, it's more quickly retrieved and brought back and then taken off to whatever the next location is going to be.
This was when performing restores, right? Because the actual backup process is faster. But the restore was.
Because it had to calculate the erasure code on the right mechanism. The Windows SUSE size again.
Yeah, this is similar to the same way we were doing it on the VMware side, maxing out the I/O size. And also, similarly to the round robin approach we're doing for VMware, on the Windows side, we have the multipath I/O available to us, particularly with multiple iSCSI gateways that we're leveraging. So these were very particular if you are leveraging a backup solution that's connecting over iSCSI to retrieve data or restore data. And then there are a couple other things. Now this will vary because these are very Veeam specific. These are things that they've got built into their software to be able to tune for doing backups. and I've got some links there for
The more detail.
on those. But if you've got Veeam, great. If you don't, try to look and see if they have similar
Concepts
kinds
of parallel
settings.
processing,
Yeah. For
per
increasing
VM
performance.
backup files,
Exactly.
and then more resources. So one of the things is the main IHV partner page. There are specific architectures, reference architectures for HP, Lenovo, Dell that you can go grab there, where it'll go into the specific hardware components that have been tested and certified for storage. So if you're just getting started, it's a nice place to kind of go look at what would a cluster look like from an HP or from a Lenovo or Dell. The S-certified page, those are the hardware platforms that have been certified on SUSE for storage. This is an interesting use case, Ceph storage in Azure, because there is not shared storage options today in Azure. They're getting there with some new offerings, but this has been an interesting solution for a handful of customers, where we're using software-defined storage on virtual machines in the public cloud to provide shared storage. So, what was that?
NetApp is doing the same to have a SLI for the customers.
Right. They're working on it. I've got a couple of customers that are on the edge of using it in their dev environment, but they're not done yet. They've got some more engineering to finish up in that Azure space. So this, we're teasing this new tuning best practices guide. This is being written by Cameron Cedar, the guy that's not here that was supposed to have been here helping us today. But he is working on this guide. It's a work in progress. It's looking good so far. But his goal is to start laying out and capturing some of the recipes. If I'm doing NFS, these are some of the tuning specifics that I'd want to do for NFS. But also building it out in a layered approach. Tuning for core storage platform. There's stuff there that needs to be done. Then there's stuff specific to NFS. There's stuff specific to iSCSI.
So a couple things also that we ran into in our own lab for performance. One thing was enabling the block and queue I/O scheduler for the OSD nodes.
Yep.
That shifts, so instead of having one single I/O scheduler, it puts a scheduler per CPU socket, and that greatly speeds up the number of I/O operations you can do on those boxes.
That'll be in that. That's going to be detailed in that document.
Yeah.
Cameron's not here, so-
Yep.
Yeah. You can fill in for him because that's the kind of stuff that we were putting in here.
And the other thing that we had to adjust in there was the number of placement groups. We started off with too few number of placement groups for the bits, and it wasn't spread out enough over enough spindles. So
Right.
we ended up having to seriously bump those. So make sure you have your placement groups correct as well.
And what Rick was referencing is we have built our own lab with a full implementation of the entire stack of SUSE components. That we're managing the whole thing. We've got OpenStack, we've got all the container solutions. There you go. So go see Rick and see the details on that. But Cameron was instrumental in helping with the cluster implementation. And a lot of the content he's putting in there was very hard won out of that implementation and a number of other customer implementations that he's worked on. So, where at? Do you know what? You know where it's at? Do you know where? So what's the title?
Geekos, clouds, and containers on mine.
There you go. So go hit that
How
one
we
this
doing on
afternoon.
time?
We're right up at it here.
Okay.
So we're at 12:27.
All right.
And so lunch is at 12:30. So we'll hang for a few minutes if you guys got specific questions. But thank you for attending.
We had the dashboard, a couple apps, a couple different tools to use. We were hoping to have time to show. So if you want to hang and come and see those, great. Otherwise, we'll see you at lunch and ask questions and look for us or look for Cameron
Or Alejandro or
Or
Rick.
Alejandro back there, glad to
We'll,
help.
we'll,
Or Michael
we'll throw them in
Carrington
as well.
standing back there, sitting back there.